Hello students, you are welcome to sirMATHS. Thank you for coming around and let us embark on this very thrilling mathematical journey together. Our discussion is for grade 9, equivalent to JSS 3. And today we are going to treat the operations of exponent, which is the same thing as law of indices, the operation with exponents. You remember or recall that we have treated this law of indices. We treated the laws and we had some examples, but today we are going to treat further example or the operations, both the multiplication, the division, the power, and the rest. So today what we are going to be is just examples for each of these sections of exponents, law of indices. So we're operations with exponents. Which I told you is the same thing as law of indices. To the variable basis and integral basis. So the variable basis, which we use any letter as a base. But for integral, we use a whole number, that's an integral, as a base. So we start with the first law, which is a multiplication. For the variable basis, we may be asked to solve this aspect of it. Y raised to power 5 and y raised to power 2. You see, why one has to be careful in mathematics is that any little thing means so many things in mathematics. You can see this very dot. This stands for multiplication. So what we have there is the same thing as y raised to power 5 times y raised to power 2, which we simply tell whomsoever that this is y raised to power 5 plus 2 according to the law, and that will give us y raised to power 7. That is for the variable basis. Variable basis. We can as well be asked p raised to power 2 times p raised to power 5. It's power 3. Like I said before, this is the same thing as p raised to power 2 as p raised to power 3, giving us p raised to power 2 plus 3, resulting to p raised to power 5. Still under this variable, we can be asked to solve t raised to power 2 times t raised to power 1 times t raised to power 4. I told you when there is no power, automatically it is raised to power 1. When there is no, we have a base without power. So this will give us t raised to power 2 plus 1 plus 4. Resulting to t raised to 2 plus 1 is 3, 3 plus 4 is 7. This is for variable basis. And then we go to integral basis, still under the first law, which is multiplication. I have integral basis. When we ask to solve 2 raised to power 2, that's 2 raised to power 3, 2 raised to power 1. Let's start with the 2 before we now go to 3 items. So this will give us 2 raised to power 2 plus 3, and that will give us 2 raised to power 5. This is a manageable number. We can continue. It's a manageable number. So 2 times 2 will give us 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 will give us 32. That is 32. We can add to treat 3 raised to power 3 times 3 raised to power 2. This will give us 3 raised to power 3 plus 2, and that is 3 raised to power 5. This is also a manageable number. We can treat this, we handle this without the need of what you call calculator. 3 times 3 will give us 9. 9 times 3 is 27. 27 times 3 will give us 81. 81 times 3 will give us 243. That is for integral. We may have more than 2. Where we are asked to solve 2 raised to power 2, as 2 raised to power 3, as 2 raised to power 1. That one may not be written, just 2. And you, like I said before, you know that when there is no power, it's automatically raised to power 1. And this will give us 2 raised to power 2 plus 3 plus 1. And that will give us 2. 2 plus 3 is 5. 5 plus 1 is 6. It's also a manageable number. We can go beyond that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. That is integral basis for the first law as we treated, which is multiplication. There are situations where the value of the number will be a very voluminous one that you may not need to continue. In a situation we are expected to solve a number such as 104 raised to power 3 as 104 raised to power 5. This is 104 raised to power 3 plus 5, resulting to 104 raised to power 8. We can't go beyond this. There's no need of raising 104 to power 8. We stop there. That is, the value is not a manageable number. This will need you going asking for your calculator or computer. There's no need for that. You stop at this very point. That is for this very first law. We are treating the second law. The second law. Very sorry about it. Let's go up to it. We discuss variable. Variable, not first law. Variable basis. This way we are asked a raised to power 5 divided by a raised to power 2. That's what I had in mind. Please, not there. So we have a raised to power 5 minus 2, giving us a raised to power 3, because 5 minus 2 will give us 3. I'm giving b raised to power 9 divided by b raised to power 3. It will be b raised to power 9 minus 3, and that is b raised to power 6. That is for variable basis. We go this way, variable basis. For the second law, let us look at the integral basis of this very second law, where we have law of division. Five raised to power 4 divided by 5 raised to power 2. It will be 5 raised to power 4 minus 2, and that is 5 raised to power 2. 4 minus 2 is 2. This is a manageable number. 5 raised to power 2 is 5 times 5, which is 25. We may as well be given 7 raised to power 6 divided by 7 raised to power 4. That is 7 raised to power 6 minus 4. That will give us 7. 6 minus 4 is 2. And 7 raised to power 2 will give us 49. For manageable numbers, we can as well have a number that is a voluminous one, where we may not need to continue. Before then, it can be a different pattern, but it will still be division. For example, 9 raised to power 5 divided by 9 raised to power 3. This is the same thing as 9 raised to power 5 minus 3, which will give us 9 raised to power 2, and that is 81. These are manageable numbers. That's why we were able to continue. But where it is beyond manageable number, we stop at whatever point where we are supposed to stop for the integral. Let's look at the number that's a big number, so to say. Actually, there is no number that is actually called big as such in mathematics presently. When we are given a number like 173 raised to power 5 divided by 173 raised to power 2. This is 173 raised to power 5 minus 2. That is 173. 5 minus 2 will give us 3. We stop here. I may not continue. We stop there for that. Let's have one example more of this very big figure. 735 raised to power 8 divided by 735 raised to power 3. This is 735 raised to power 8 minus 3. That will give us 735 raised to power 8 minus 3 is 5. That is a number that is not manageable. We can stop there under this very second law of division. That is, let's go to another one as we discussed. This is that of power. That of power, let's have a figure like this. That is still variable first, variable basis. We have W raised to power 6 or raised to power 4. That will be raised to power 6 or raised to power 4. So that is W raised to power 6 times 4, giving us W. 6 times 4 will give us 24. We can be given A raised to power 3 or raised to power 2. That is A raised to power 3 times 2, resulting to A raised to power 3 times 2, 6. That is the law of power. We multiply the powers. For variable basis, what about integral basis? Under this very law, integral basis two raised to power 2 or raised to power 3. This will be 2 raised to power 2 times 3. And that is 2 raised to power 6. 2 times 3 is 6. You will agree with me that this is a manageable number. And that will result to 32. That is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Okay, that is, and 32 times 2, 64. Is good. We went back to it. This is 64. It's 2 raised to power 5. That is 32. This is 64. We continued because the number can be managed. But where it is it will be more than that, we can stop so far. We have 11 raised to power 5 or raised to power 4. This will result to 11 raised to power 5 times 4, and that is 11 raised to power 20. We can stop there. That is this very particular law in these very operations. We can stop there in this, that very one. Let's go to another bigger figure where we have a combination. Let's look at combination. The combination we can be given A raised to power 5 or raised to power 2, A raised to power 2 times A raised to power 1. So we have this. This is said as A raised to power 5 over A raised to power 2 plus 1. And that is A raised to power 5 over A raised to power 3, giving us A raised to power 5 minus 3. And that will result to A raised to power 2. Power 2. So their situations will give in a value that let's have 1 4 7 3 raised to power 6 over 4 7 3 raised to power 2 4 7 3 raised to power 3. This will give us 4 7 3 raised to power 6 over 4 7 3 raised to power 2 plus 3, resulting to 4 7 3 raised to power 6 over 4 7 3. 2 plus 3 is 5. That will be 4 7 3 raised to power 6 minus 5. That will result to 473 raised to power 1. We may not try the 1. That's this very aspect. So we are treating operations with exponents, which is the same thing as the operations with lot of indices, the variable and the integral basis. I still encourage you to ensure you subscribe to sirMATHS just by clicking the subscription and the notification button. You will be updated. You follow us in this very wonderful and thrilling mathematical journey in the world of numbers. Thank you for participating today. By God's grace, we meet again next week.